Hey everybody, I'm Raphael Eidus. Oh, this is my first slide. This is my first slide. So I'm going to talk about building a large-scale React Native app, um, and just sort of the lessons that we learned from moving HuffPost mobile application to React Native. Right now, we've launched our Android app, and it's available in the Play Store, and we're working on bringing over iOS. So a little bit about me. My name is Raphael Eidu. I'm Director of Engineering at HuffPost. My primary background throughout my career has been in web development, but for the last 2 years, I've been leading a mobile app development team. Um, so, what is React Native? At its core, it's a bridge, a message bus between JavaScript and a C thread, which then communicates with Objective-C or Java. But really, that is fundamentally what React Native is. It has some other pieces layered on top, like a React component lifecycle, which is great and makes it super fun to work with. But fundamentally, it's always good to remember that what you're dealing with is a message bus. Um, it is a hybrid application framework. It's not a web view. A lot of people who have worked with in the past with hybrid application frameworks expect it to just be a web view, and it's not that. And all rendering and interaction is done by a native UI thread. So a little bit about our approach, but before that, here's what it looks like. Sometimes it looks like this, also this. Sometimes it looks like this, and a little too often than not on my computer, it looks like this. Um, so some architectural objectives. What were we trying to achieve while building this? Strong offline support, minimal network usage. You'd want that out of a mobile application. Adherence to human interface guidelines. So Apple publishes their own. Google Play has material design, which isn't as strict, but we're in that space, so we want to adhere. Strong static type coverage, UI test coverage, maintainability through code predictability. We wanted developers who were familiar with the best practices of React applications to be able to sit down at our code base and instinctively know where to find code. Safe database migrations, and a very strong separation of concerns. Today I'm mostly going to be talking about the separation of concerns. So we thought about four main pillars to our application. Layout and styling, so we're using JSX and a subset of CSS to do component styling, nothing groundbreaking. App logic, so what was important was that there is a division between just the layout and the styling and the application logic, our business logic. So we try to extract that out as much as possible from the just strict UI layer. State management. The state for mobile applications is larger than most web applications. And asynchronous tasks. There's a lot of stuff in the mobile world that has to happen sort of behind the scenes, and being sure we have a clean way to do that while still allowing our UI to keep updating. Some challenges that we faced. Memory usage, rotation performance, start time, gesture recognition, debugging. The debugging has come a really long way since we started the project about a year ago. The tooling has just advanced a ton. Cross-training developers. So our team primarily is coming from JavaScript background, but we do have some members coming from iOS and Java background. But everyone on the team has been trying to learn the other stuff to at least like be able to look at the code and know what it does and maybe work off of a boilerplate to add functionality. And some limitations with asynchronous storage had bit us along the way. So here are some opinionated recommendations. Use statically typed JavaScript. Shipped code is really slow to roll out. On iOS, the App Store has a review process that's between 2 and 5 days before you can get it available to users. On Google Play, it's between 3 and 6 hours. and that's just the time to get it available in the App Store. Our process to get 95% of our user base onto a new version, that takes a month. So if we introduce a bug that type safety could have helped us catch, there is going to be a substantial chunk of our users who are using that bugged version of the application for a month, and we wanted to avoid that. And we consider every release that we ship supported for 2 years, because that last 5%, that 95% I spoke about, the other 5% is app code that goes back 2 years, if not longer. After that, we're just like, okay, we can't keep supporting that. So you can prevent a lot of bugs with static typing. It helps you a lot. It also just, as someone who fought against it for a while, now that I've been using it, I like what it does to my editor and turning it into an IDE and like being able to see code hinting. Typing after the fact is hard to do. So if you have the chance to start sooner rather than later, start. But don't let that deter you. If you've like started a project and gotten pretty far, there are benefits to gain from adding typing. Use a state manager. Unless you know your application is going to stay dead simple for the life of it, pick up a robust state manager early. So Gant Laborde started this repository and wrote up this blog post called the React State Museum. It lists over 32 different solutions for state management and their interaction with React. 21 of those have examples written in React Native. There's a lot to choose from. We chose Redux. Redux is great. Its tooling and ecosystem are really mature. It's very extensible. It's easy to debug. Things like persisting the application state to disk. So if you want your application to be able to, like, wherever the user was, they close it, they close the application, and then they reopen it later, and it goes right back to where they were exactly as they had it. There's Redux Persist, basically no code. You can get that for free. So that was really nice. Redux State sometimes looks like a cache, but it's not a cache. And this has been sort of a continuous little struggle that we have of we keep sort of trying to use it as a cache because we haven't found something better for certain types of resources. But it requires some weird patterns to use it in that way. For long-term storage, we decided not to use Redux and Redux Persist. So things like user settings and preferences where they provided input, we store that in Realm database. Ultimately, we wanted to make sure we wanted it so that if we ever needed to migrate the shape of our Redux state, and it was just too much work to write a migration script for it, we wanted it to be just totally fine for us to just throw it all out and start fresh for every user on app upgrade. We haven't had to do that yet, but that was our principle. Like, nothing that lives in Redux should be it should all be ready to be destroyed at any moment. And that's been beneficial for us to have that boundary of like what's permanent and what's not. Ultimately, there's a lot to say about Redux, and I don't have time to say it all. But fortunately, in about 45 minutes, there is a talk on this stage about Redux and React. So I recommend checking that out. So where was Redux difficult? It has a little bit of a heavy mental overhead, I found. Just a lot to like be thinking about while you're working with it at times. It has a lot of boilerplate. And statically typing it was a little tricky at first. We had to monitor the memory footprint. We found at one point that our Redux state had like 100 megabytes in it, and we weren't properly removing things from state. So that was something that tripped us up. So logic layer. React makes it really easy to separate view and app logic, but it doesn't do it for you or require you to do it. So be disciplined and keep things separate. Create business logic modules and include them as needed into your view layer, but having them be separate. Leverage the NPM ecosystem to bring in solutions to solve problems. Okay, I wrote this slide before the event stream attack that infected 4,000 NPM packages, but I stand by that point. There's a lot of really great stuff out there. We use Moment.js for dealing with dates and times. We use Superstruct to validate our API response, because in the past we've found like sometimes our API structure just changes with no warning or explanation, and the app will start crashing. So we've taken a defensive approach where every single request we validate that it looks like what we expected it to look like. Yeah. And deviate on iOS and Android at times when it makes sense. So I think it's really easy to get caught up in like it's one code base for both, so like all the code has to be the same. At times that's actually more of a headache than it's worth, and you should take advantage of how easy Metro makes it for you to diverge certain features. That being said, if you end up with like a giant iOS folder and Android folder with huge component trees, you might have done something wrong along the way. So style components individually. The container components or container components pattern is great for attaching state to components. Always do every animation that you possibly can with native driver. It will improve your performance a lot, and it's pretty easy to do, but it is something that you have to think about. Avoiding long lists. React Native has struggles with long lists of content. There are steps you can take to mitigate them. If you can just sort of avoid doing them, even easier. Reducing extra views. So coming from a web background, wrapping something in a div basically has no cost. Browsers are great at it. In the native world, that's an extra cycle over the bridge. So that's an extra native component that has to be built. In addition, the way iOS and Android optimize their view layers, if you wrap like 10 things in one view, that entire view has to be rendered at the same time. It can't, whereas if those are 10 separate objects, when they move out of view, they can get de-rendered. So that's definitely something that basically every web developer that I've seen start using React Native has wrapped things unnecessarily in extra view tags. So it's definitely something to look out for and avoid. And then, as with all React projects, avoid extra re-renders. They seem to be a little bit more costly in React Native. So memoize your component data selectors, use pure components when appropriate, and definitely rewatch Jean Remy's presentation from earlier today about performance debugging, because it's great. For navigation, we use React Navigation. It's excellent. It's the all JavaScript solution to React Native navigation. React Native navigation is less customizable, but in general has better performance for free. You can have a lot of performance problems with React Navigation. We heavily used the Stack Navigator. So for those of you who aren't familiar with mobile application development, whenever you have in an application, you click a button and a new screen sort of comes over it, that's a Stack Navigator. Well, when you're doing normal native development and you're using the free tools from iOS and Android, when you push things onto the stack, the items underneath get sort of taken away. They're no longer there. But in React Native or React Navigation, that's not true. They're all rendered underneath each other, on top of each other, which can have some real problems for memory footprint. So there was recently an effort done to show this. So this is a stack navigator. You can see in the top left, 750 megabytes of memory is what this application is currently consuming, and I think it has like three stacks. The exact same application with React navigation screens, or React Native screens. So this was 2 lines of code, 1 additional library and 2 lines of code, and it's about half the memory footprint. So there's new things being done to address this, but with your navigation structure, you are going to want to look out for memory usage. So yeah, the bridge and native code. Early on in our project, as we were sort of looking at what we would need to do, we knew we weren't going to be able to do everything with community React Native projects and just JavaScript. We knew we weren't going to be able to use Expo. We needed our own native code. So we got familiar with the bridge. So that meant thinking about and looking at how many messages are going back and forth over the bridge, because it can become a bottleneck. And then figuring out what kind of tasks we wanted to do on the native side. So only native code can do work on background threads. JavaScript, it's all single-threaded. You can do things asynchronously, but ultimately it's still on the same thread. So if you're doing anything with image manipulation, like if a user provides an image and you want to like resize it down before uploading it to a server to save on bandwidth, if you do that in the JavaScript thread, it's going to lock your user interface while that's happening for no real reason. So if you can write a native module where it's doing that on a background thread, your interface is still usable. Sound processing, there are a lot of things. If you can ever possibly do it in a background thread, you probably should, which means you should look at sending it across the bridge and doing it in native code. There are no synchronous bridge calls yet, but it's coming soon. It's been promised in future versions of React Native, and this will open up a lot of new use cases and make a lot of current things that are sort of difficult to do and to reason about much simpler. So be on the lookout for that. iOS and Android APIs don't always need to be the same when you're implementing a bridge module. We've often found like the solution's a little bit different. The way you call the functions isn't quite the same on the two platforms. So the approach we took is, instead of trying to coalesce them in Java and Objective-C to get them to like look the same, we exposed the 2 different APIs over to JavaScript and then had JavaScript coalesce them to where it was wrapping, like on iOS there might be 2 functions that combine to do what was 1 function on Android. So creating just a function in the JavaScript layer that calls one and then the other is pretty easy to do. So we found it easier to make things match on the JavaScript side and let the bridge modules be a little bit different on the native side. Yeah, and they're pretty straightforward to implement once you try one. So I really do recommend digging in on it. And if you can, submit it back to the open source community. This community, I think, really needs more native modules that bring in unique and interesting functionality. The direction React Native is taking is the core framework is actually going to shrink. There's a lot of stuff in it that most of us never use. So I think the first thing that's being removed is actually the web view. So React Native Web View is going to a standalone library. And I think what we'll see is the actual core framework will be closer to what I talked about it being at its core just a bridge. And it's going to be mostly the bridge, and then it's going to be you pick what modules you need. And going back to that memory footprint issue earlier, when you're instantiating the entire framework, it's a lot. The application is pretty huge, and it's really easy to have problems with that. When we originally launched on Android, our most significant crash affecting users was out-of-memory errors. And that's been something that we've that took us a while wrestling with. So I'm very much looking forward to the smaller React Native framework with more access to React Native components that are included as needed. Yeah. So React Native works for large applications, but there are definitely hurdles. So plan ahead and yeah, and definitely contribute back to the community. Yeah, thanks. I think I was way under. Um, a quick thank you to Slides Carnival for the deck template. And if you want to download the Android app, it is on the Play Store if you search for HuffPost, or I think that QR code is not high enough contrast for it to actually work, but the URL that's up there will. Yeah, and I'm going to be around if anyone has questions. I would love to talk to people.